Level 0. The sky that kills people looks completely fine at noon. On some of the deadliest tornado days in recorded history, the morning was sunny, the afternoon felt warm and slightly thick, and nothing visible communicated what was already being assembled kilometers above. Tornado formation does not begin with clouds. It begins with two rivers of wind blowing in different directions at different altitudes, and you cannot detect either from the ground. This is wind shear. Without it, not a single tornado on this planet would exist. When surface winds push north at 30 kilometers per hour and upper-level winds drive from the west at 90 kilometers per hour, that difference creates a horizontal spinning column of air, like a rolling log lying on its side across the lower atmosphere. The thunderstorm developing inside that environment tilts that horizontal spin into the vertical. When it does, the chain of events leading to a tornado has already begun, what most coverage never says out loud. By the time you see the first suspicious cloud, the atmosphere has been running this process for 3 to 5 hours, and those hours look exactly like a normal afternoon. Once that spin tilts vertical, the storm needs somewhere to put all of that rotation. Where it puts it is invisible, enormous, and already deciding your fate. Level 1. Most tornadoes are born from a storm that is already rotating as a whole, not a funnel. The entire storm. A supercell thunderstorm develops a rotating updraft column called a mesocyclone, typically 5 to 10 kilometers wide, invisible from the ground. It leaves no condensation trail. The storm simply looks dark, wide, and wrong in a way that resists description. On Doppler radar, it appears as a velocity couplet, winds moving toward the radar on one side and away on the other, side by side in the same small region. Experienced forecasters recognize it immediately. What they feel is not excitement, it is urgent. The surprising part, the mesocyclone alone does not produce a tornado. Hundreds form over Europe and North America every spring. Most never produce anything at the surface. We can track the rotation from space, measure wind velocities with mobile radar, model the thermodynamic environment with supercomputers, and still cannot tell you with confidence which supercell will produce a tornado in the next 30 minutes. The storm keeps its final decision private until the last possible moment. What forces that decision is a current of descending air on the storm's backside, and it acts as the trigger for everything that follows. Level 2. While the updraft pulls warm surface air upward, something descends on the opposite side. The rear flank downdraft is a current of cooler, drier air sinking toward the surface along the back flank of the supercell. As it descends, it carries upper-level momentum downward, compressing the rotating air column and accelerating rotation near the ground. It stretches the vortex downward, the way pulling both ends of a piece of clay thins and spins up the center. This is vortex stretching, and it is the moment a rotating storm becomes a tornado producer. Storm chasers can feel this before they can see it. The wind shifts direction abruptly. The air cools a few degrees. Leaves begin circling on the ground. Pressure changes in the sinuses before the brain has processed it as information. The storm often tries to produce a tornado and fails. The vortex stretches partway toward the ground, a brief circulation forms, then collapses. The storm reorganizes and tries again. This cycling process, called cyclic tornadogenesis, can repeat 3 or 4 times before the storm finally maintains the connection. Multiple failed attempts, one that succeeds. When persistence finally wins, the storm announces it with a signal that has been dangerously misread more often than almost any other weather feature on Earth. Level 3. A specific region of the storm base begins to lower, roughly 3 to 8 kilometers wide, directly beneath the mesocyclone. This is the wall cloud. It descends because the air feeding the updraft there is so moisture-saturated and the pressure so low that condensation forms at a lower altitude than the surrounding cloud base. It rotates slowly at first, then with increasing urgency. The misconception that causes the most harm. People assume the rotating cloud itself is the danger. It is not. The wall cloud is the advertisement. The danger is what it connects to above, a mesocyclone already rotating at speeds capable of destroying anything caught in its core. Some wall clouds rotate for 45 minutes without producing a tornado. Others drop a funnel within 3 minutes. There is no visible countdown. Most people who have died in tornado events had warning time. The failure was not information. It was an interpretation. The next stage moves faster than interpretation allows, and it begins with something that often cannot be seen at all. Level 4. The funnel drops. It does not always look like what people expect. Sometimes it descends cleanly, unmistakable. Other times the visible funnel barely extends past the cloud base, and this is the detail that has caused deaths. The condensation funnel only marks where pressure is low enough to condense water vapor. The actual rotating column extends much further down than the visible funnel suggests. Tornadoes have produced EF1 damage, winds of 138 to 177 kilometers per hour, while the visible funnel was still 30 meters above the surface. The rotation was already there. The destruction was already happening. The cloud simply had not caught up. The real signal is the debris cloud. At the contact point, soil, vegetation, and loose material are ingested into the vortex. That rising mass of debris identifies exactly where the tornado is, not where the condensation funnel appears to be. The debris cloud does not lie. A tornado does not announce its intensity at birth. A vortex making first contact as a narrow rope can intensify to EF3 within 2 minutes. The rope stage is not a guarantee of weakness. It is simply the geometry of a vortex that has not yet organized its full structure. It expands next, and expanding, somehow, makes it faster. Level 5. A tornado growing wider should mean the rotation spreads out and slows. That is the intuitive expectation. The atmosphere disagrees. As surface inflow strengthens, warm, humid air races into the base of the vortex at speeds that would qualify as severe weather on their own. Research vehicles have measured inflow wind speeds of 160 kilometers per hour at the surface, not inside the tornado, but in the feeder current approaching it. That acceleration stretches the vortex vertically, and the more it is stretched vertically, the faster it spins. Intensification is a feedback loop with no natural ceiling until one of the inputs disappears. Inside the widening core, suction vortices form, smaller, intensely rotating columns orbiting the interior of the main vortex, each carrying localized wind speeds that can significantly exceed the average of the parent circulation. They explain the damage patterns that look arbitrary from above. A home leveled to its foundation next to a home that kept its shutters. The suction vortex passed over one and missed the other by 20 meters. Not random. Precisely determined by orbital geometry. Most tornadoes weaken somewhere in this phase, but a small fraction of supercells refuse to release the rotation, and what they build next is the point where scale stops being a measurement and becomes something you feel. Level 6. There are tornadoes that look, from a distance, like the horizon is rotating. Not a funnel, a wall. A rotating wall of darkness from the ground to the cloud base, wider than it is tall, with no visible edge on either side. The accounts from inside are consistent on one detail. It did not feel like weather. It felt like the world changed. The El Reno, Oklahoma tornado of the 31st of May 2013 reached 4.2 kilometers wide at peak width, the widest ever recorded. It killed professional storm chasers with decades of combined experience and real-time radar because the circulation extended kilometers beyond the visible condensation funnel. The tornado was substantially larger than what anyone could see. At EF4 and EF5 intensity, winds above 267 kilometers per hour, the damage reads like a different category of event entirely. Reinforced concrete compromised, foundations scoured to bare earth, trees stripped of bark by debris moving at over 300 kilometers per hour. The EF5 category exists because the lower categories ran out of vocabulary. What scientists say carefully when the conversation reaches this point: we do not know where the upper boundary is. There is no physical law preventing a tornado wider than 4.2 kilometers. What we have are measurements from the events that have happened so far. There is no known ceiling on this. El Reno was 4.2 kilometers wide and still didn't test whatever the actual limit is because nobody has found it yet. Every model, every historical record, every category on the EF scale is built from what has already happened, not from what's physically possible. That's the unsettling part of level 6. It isn't the top of the scale. It's the last point on the scale anyone has confirmed.